Am I the picture? Is this guy?
Yeah. Yep.
Yeah.
Yep.
So this would be number, well, 15's in the back of the book. You know that's fair game for the test. This is 16.
Sure. Yep.
So you should have that two things handy. Not only tonight, but when you're doing these on your own, and you can have them on the final as well. That proof strategy document that's on Blackboard, where we have about 5 strategies listed. And also a nice chart of our 10 rules. I suggest the way I presented them on the board, not necessarily the way they are in the back of the book. So our first 3 strategies are definitely most commonly used, especially the first one. In that case, you want to recognize either the entire argument or parts of it as resembling something from our first 9 rules. When you do recognize that, it's there. That's the key to the proof, definitely. Secondly, you want to note obvious replacement statements. Definitely those that are spot on. Maybe some that are very, very close that you're able to recognize. I'm not sure what I have third and fourth as strategies, but one suggested by the author, and it's also on that proof strategy document. If there are a letter or letters, that is simple statements in the premises but not the conclusion, in a sense they've got to be gotten rid of in the proof procedure. They have to be left behind. And the way we leave them behind or get rid of them is with those rules that we were calling extraction rules previously, which still are extraction rules. That would be simplification, disjunctive syllogism, modus ponens. Then, if none of that is working, sometimes the conclusion itself has replaced the immediately prior step. When that's the case, the proofs are real difficult to figure out because we're always trying to derive the conclusion. But it turns out, if it is a replacement statement of the previous step, we need to note that and try to derive that statement as the next to the last step, and then simply replace it. Then I think my desperation strategy is none of that's working, and you're pretty good at those. Start replacing what you can off to the side, and you'll have more to look at. Maybe one of those better strategies will become available to you. Well, let's see what we have going on here. I think that you should recognize that first premise and our conclusion as related to each other as the first premise and the conclusion of one of our first 9 rules of inference. So I want you to figure out what that is. This is a disjunction, and our conclusion is the right-hand disjunct. So what rule are we describing there? Disjunctive syllogism. Okay, that's the key. It's there. Second, well, let's go ahead and have a look at that disjunctive syllogism off to the side. You should be able to figure out what the second premise has to be. Let me move this over a little bit. Right? What's the second premise of our disjunctive syllogism? P wedge Q, curl P, therefore Q. So what's our second premise in this case?
Curl S
S,
and T.
and T.
Right? Okay. This premise right here has to be turned into that. So what we want to do is recognize this is an obvious replacement statement. That's why you have to be familiar with these rules. It's indispensable. That's a real obvious one. It's a disjunction of two negations. So scope it out. Find it on your chart. Find out what rule it is. Let me know when you get it. It's one of the statements of De Morgan's theorem. So, is that a direct replacement right there? If we simply replace line 2, are we going to have the second premise of our disjunctive syllogism? Yeah, we sure are. So that's our proof right there. We recognize that first premise and the conclusion as the first premise and the conclusion of disjunctive syllogism. We recognize line 2 as a De Morgan statement and figured that if we simply replaced it, we will in fact have the second premise of our disjunctive syllogism. So that's it. That's the proof. All right, questions about that one? Good, erase. Am I still in?
We go do it again. Okay. Just put your finger by it. No, just let it stay there. That is. Yeah, that's it.
Yeah.
Yep.
Number 17. Okay, this again is our best strategy, number 1 on our list. You need to recognize the resemblance of this entire argument to one of our first 9 rules. So I want you to find that. As soon as we identify that, that'll be the key to this proof. First 9 rules of inference. You understand when I say resemblance, I sure don't mean it's, an exact substitution. What? Absorption? No, I'm saying this entire argument, both premises and the conclusion, are very close to one of our entire first 9 rules of inference. Hypothetical syllogism. It's close enough. Now, that conclusion is not going to change. So let's see what we need. This is a 2-step proof. And we're confident that hypothetical syllogism is our last step. Okay? And these premises don't match for hypothetical syllogism. So it follows that one of them has to be changed in one step to complete our hypothetical syllogism. This one's not going to change because we absolutely need Z in the consequent position. Right? This is the one that we know has to change because we know that we need W in the antecedent position. So this is the one that has to change. Right? This one's going to stay the same. I'm very confident. All right, you need to recognize this as an obvious replacement statement. Thank you. It's an exportation statement. Check it out on your list or your chart. Figure out what it becomes. Try to widen this a little bit. That's pretty good. I can move that all over a little bit.
Yeah, if you wanted to put some more stuff in.
Does it in fact become this? Is that the replacement statement by X? Okay, that's it then. So once again, you recognize the resemblance to one of our first 9 rules of inference. Then we recognize this as an obvious replacement statement and determine that by replacing it, we would in fact have our hypothetical syllogism. So that's our proof. First this, and we're ready to go. Good. Erase. Again, we have pieces. We don't even have to change them around. We have pieces of one of our first 9 rules of inference. Those pieces are that first premise and the conclusion. So I want you to identify which one of our first 9 rules those are the first premise and conclusion of, because that is the key. First premise is a conditional statement. Second premise is the negation of the antecedent. What are we describing there? Are we saying modus tollens?
Yes.
Yeah. Okay. So, the second premise of our modus tollens has to be the negation of this. Agreed?
Yes.
Okay. Now, you need to recognize this as an obvious replacement statement. It's spot on. It's a conjunction of two negations. So find that somewhere in your chart. It's one of De Morgan's theorems again, one of the statements. So verify that if you simply replace this by De Morgan's theorem, you are in fact going to have our second premise of modus tollens. Does that seem to be the case?
Yes.
Yep. And that's it. We're simply going to replace line 2 and we'll have our modus tollens ready to go. So almost all the time, almost every proof is your ability to see either pieces of or resemblances of one of the first 9 rules of inference. Figure out what has to be changed, usually by replacement. And that's the proof. 9 times out of 10. They do get more difficult than that, but very common. So we're going to replace this, line 2. Good? Number 19 is almost too easy to bother with. Really? You'll agree. Ready? Boy, if you don't look at that too closely, you'd think we have exactly one of our first 9 rules of inference. Figure out what it is. One of our oldies but goodies. Modus ponens, the affirming mode. There's only a very subtle problem with it. Easily fixed by a replacement rule. What's wrong with our modus ponens? It's this, right? That's the only thing lacking. Yes? Commutation. Commutation. Now, do you think it matters which dot I replace by commutation? Would it matter? If I replace this with this, we'll have modus ponens. If I replace this with this, we'll have modus ponens. Does it matter? No. It doesn't matter. I'm going to save some ink and replace line 2. See, otherwise I'd have to write out the rest of that premise. Right? That'll work. Easy one. You're getting warmed up? You're going to have to branch out on your own for some of these. '20's in the back of the book. Don't forget about it. This is 21. Once again, we have very nearly, in its entirety, the whole argument is very close to one of our first 9 rules of inference. Have a look around. First 9. Real close. Somebody says constructive dilemma. Yep. See how that works? You find one of those first 9 rules embedded or hidden in the argument. It's almost always the key to the proof. What's the only problem? This. That's the only thing holding us back from constructive dilemma. Okay, now you can look at this one of 2 ways. Probably the best way would be to be able to recognize that component. Remember, we can replace components of a line of proof or the whole line of proof. You should be able to recognize that as one of the real obvious ones of our 10 rules of replacement. Or you could tell yourself this. For constructive dilemma, this, at least I know this needs to be a horseshoe. And I have a wedge. So if you wrote down, first day of this part of the course, if you wrote down my little descriptions of what these rules of replacement do, one of those is described as trading horseshoes and wedges. All right, so have you found what rule of replacement we need to use to turn that wedge into a horseshoe? Material implication. See, then that's it. We're going to replace that component by material implication, and we'll have our constructive dilemma. Go ahead and verify that. Get the proof in your notes if you want. Okay, you should be well on your way. We're going to replace just that component. And we have our constructive dilemma. 3-2. This is almost easier than using just the first 9 rules because there's more creativity involved. You don't have to stick to that, absolute procedure that we were following before. Holy cow, 22 looks ungodly. Look at that. It's easy though. Just long statements, that's all. Well, we have a conjunction of 2 horseshoes. Maybe we should consider, like right now, like back in the old days, either simplification or constructive dilemma. Right? As a conjunction, it's subject to simplification. Conjunction of 2 horseshoes, constructive dilemma. Let's see how it plays out. Do you remember what I told you about double negation when our argument already has 2 curls in it? No, because I said if the argument has a double negation, most likely we're going to be removing them by double negation. See, we would want to add 2 curls when we need it for modus tollens or disjunctive syllogism in certain cases. What do you think about that? I'm going to let you figure this out. We have noticed enough, I think. always have to make identifications. They're the keys to the proof. So what did we say? Maybe construct a dilemma, maybe simplification. And we said, probably going to get rid of those two curls. Well, do things become crystal clear when you get rid of those two curls? Let's see. By golly, those are the premises of constructive dilemma. That's the conclusion of constructive dilemma. So that's what's happening. Agreed? "23 looks intimidating, but it's not. I think it will succumb to our strategies. Although, not ones that we've used tonight, but things we have discussed. Let's see. Or maybe it is one that we've used tonight. Maybe I misspoke. Let me know when you get any ideas, and then I'll point out something to you. Forget about how long and complicated they look. Start out with your first strategy always. You have pieces there. Not the whole thing, we have pieces there of one of our first 9 rules. Always look for that first. First 9 rules. In fact, those are the pieces. What are we looking at there? Thank you. We're looking at the first premise and the conclusion of modus tollens. going to let you look at that for a few seconds, see if you get any ideas. Give up? No. Well, one approach you could take is to say, if this modus tollens is going to happen, I should know what my second premise has to be. What does it have to be?
Tribar 3. I mean, B.
I mean, why not do that? If this is in fact how it's going to end up, modus tollens, and I have the first premise, I know what my second premise has to be. Okay, look. This is what you have. That's what you need. Figure it out. What is?
You good?
See what's in those brackets? That's one of your statements that simply becomes the tribar. Right? So we're just going to do this. Right? Now, admittedly, we could have replaced this with all of that, and that'll work just as well, but it's a lot of writing. How are we doing? Good? Bad?
Good.
Good. Oh, a confidence builder. Figure out what that is right there. You have a couple of replacement statements right there. I would not recognize this as having anything to do with our first 9 rules of inference. those are, each one of them are obvious replacement statements. The NBA draft.
The lottery just
Yeah.
went in. So.
Well, did you find what rule of replacement or rules of replacement we're looking at there?